Sure.
Here's the circuit that converts roughly 12 volts DC into 183 volts AC. The way it works is the power comes in 12 volts and then is lowered down to 5 volts with a 7805 voltage regulator, and then that goes to this first integrated circuit here, which has 6 inverters in it, which basically takes a logic signal on the input and outputs the opposite. So if it inputs a high, then it outputs a low, and if it inputs a low, it outputs a high. And then with this capacitor and this resistor, it creates an oscillator, which is going about 1300 hertz, and then the output is inverted, and then inverted again, and then inverted again. So then you get basically one wire is high while the other is low, and then it swaps, and it's doing that 1300 times a second, and then that is sent over to these 4 integrated circuits here that are wired up in parallel, and they are L293D motor driver integrated circuits, and that signal is put over to here, and then all of those are in parallel, so then it's switching very powerfully 2 wires back and forth, very powerfully, up to about an amp, and they are powered directly from the 12 volt supply. And so then what you end up with there, with these 2 wires here, is 12 volts AC, approximately. So then those 2 wires go here, and then here's a transformer. This was originally a 120 volts to 12 volts transformer, so it's a 10 to 1. But I just plugged this into the 1 side and then into the 10 windings side. Then I put a outlet and then hooked my voltmeter up to that, and then when you flip it on, then you can see it's applying 180 volts AC, which is too much for an outlet. However, when it's under load, it lowers down a lot. So let's try it out with a light bulb. So I found an LED light bulb here. Now it's important to note that with this particular circuit that I built, it can only supply about 10 watts of power, which is fine because this light bulb takes 9 watts of power. Anyway, let's disconnect these probes, and then I'll put one probe against the one side of the light bulb, and then I'll put the other probe against the other side of the light bulb, and flip the circuit on, and I'll touch the probe against the tip, and there. It works. Now this circuit is only generating a square wave, not a perfect sine wave, so if you try to power an AC motor with it, for one, it would just be taking too much wattage and it wouldn't be able to supply it, most certainly. But it is not a sine wave, so it would not run the motor right. It needs a sine wave, not a square wave. So now, in addition to the original transformer, now I hooked up a non-linear variac, which is meant to go from 120 volts and then have a range of off all the way up to 120 volts if wired correctly. This is an old style dimmer switch back before they were digital. It is just a transformer in there with multiple windings. Since I wired this in reverse, it should be boosting the AC voltage, not lowering it. So basically when wired in reverse, what these numbers should be is 10 windings, 11 windings, 12, 13, 14, 15, and so on, up, with the base one being 10 windings. So basically when you start here, it should be what we were already getting out of that transformer. Let's see here, 160. Okay, so now, if I start clicking it up, it should start going up even more. There's 270, and then 320, and then 350, and now back lower to 340. Now the reason that it went back down when I clicked it up even higher is that my circuit cannot provide the necessary current, so when it's under an even greater load, then it just dies and can't actually supply enough current to keep upping the voltage because there's no current left to go across the coils. So it looks like about 350 volts is the most we can get out of this configuration. But if I had more of these L293D ICs, which I don't at the moment, then you would be able to keep clicking this up way higher and get well above 1,000 volts, which this voltmeter can't handle, so I would have to figure out some other way of measuring it as well. But realistically speaking, if you wanted to make a perfect inverter, a DC to AC converter, what you would need is some sort of analog to digital converter that would basically have an 8-bit converter, essentially, to have 256 steps all the way up to high and then all the way down to the negative high. So then it would be close to a perfect sine wave. Still wouldn't be perfect, but it would be more perfect. So electric motors would be able to run on that. However, I do not have that, and that would be extremely complicated. But that is what most DC to AC converters for cars are made with. But this is a much more simple one that you can use to power a light of some sort. And then, going even further than that, I could put a bridge rectifier on this, on the output of this, so it would just essentially be a DC booster converting 12 volts DC all the way up to like 200 volts DC. But I don't have anything to power with that, so I won't be doing that today.